All right, we are up to Unit 6, Sections 4 and 5, test review. So, again, this is a binomial times a binomial, but these are called conjugates. And if you notice that they are conjugates, there's no reason to FOIL it all out because the outside and the inside will always cancel. You just need to FOIL. So, if I go 3 times 3, that's my F. If I go that's my last, square root of 5 times negative square root of 5. So we've got to be careful here. This is 9. A positive times a negative is minus, and then the roots fly off. So that'd be 4. This one, what do we have to be careful of? Don't you dare square this and think you're getting it right. No, no, no. This is saying square the binomial. So it's the square root of 7 plus 1 times the square root of 7 plus 1. Now these are not conjugates. Notice, conjugate, this is the same as this is the same as this, but this is a plus, that's a minus. These are both pluses, so I have to FOIL this out. So, square root of 7 times the square root of 7 is 7. Outside, square root of 7. Inside, square root of 7. 1 times 1 is 1. So 7 plus 1 is 8. Square root of 7 plus the square root of 7 is 2 square root of 7, and you're done. Question is, are these conjugates? No. So what do I have to do? I gotta FOIL this out. So here we go. 2 times 5 is 10. 2 times negative square root of 5 is negative 2 square root of 5. Multiply this. I get 5 square root of 5. And then a negative times a positive is negative. Square root of 5 times the square root of 5 is just 5. 10 minus 5 is 5. Negative square root of 2 square root of 5 plus 5 square root of 5 is 3 square root of 5, and you're done. Go on to this one. Once again, don't you dare square this and think you're doing it right. You have to go like this. You have to take the binomial and multiply it by itself. Now on this one, I'm going to do what I showed some of you in class, well, all of you in class, the FOIL box. So I'm going to put the 2 square root of 2 there, the square root of 5 there, just because I don't have space, and I'm going to rewrite this one along the side here. And then I'm going to multiply these together. So 2 times 2 is 4. Square root of 2 times the square root of 2 is 2. 4 times 2 is 8. Water and water, this would be 2 square root of 10. And then, again, multiply this by this. I'd get 2 square root of 10. And then square root of 5 times the square root of 5, the roots fly off. 8 plus 5 is 13. 2 square root of 10 plus 2 square root of 10 is 4 square root of 10, and there would be my answer. All right, now on these, look how they're trying to bait you into something. 15 is divisible by 3, 15 is divisible by 5. This is a situation where you cannot even consider that because of the plus. We talked about it in class, but now how do we get rid of the square root in the denominator? We multiply by the conjugate. Now, if we do that down here, we got to do the same thing to the top. I'm going to take care of the top. So that's the square root of 45 minus the square root of 75. So square root of 45 minus the square root of 75. This is 9 and 5, which is 3 square root of 5. This is the square root of 25 and 3, so it's minus 5 square root of 3. Now that's what goes in the top. Now in the bottom, I'm going to highlight this because it's getting a little messy and there's not a whole lot of room, but as you notice, this times this is considered conjugates. So we can take a shortcut and just So what's the square root of 3 times the square root of 3? Well, that would be, I'll write it down here, 3. What's the square root of 5 times the negative square root of 5? Well, first of all, a negative times a positive is negative, and then the roots fly off. 3 minus 5 is negative 2. So I would take the answer to the top and put it over negative 2. Now what I'm afraid of is they won't leave it like this. They'll take the negative and they'll throw it through the top, both things. And so they might, and then they'll reverse it. So they might write it as 5 square root of 3 minus 3 square root of 5 all over a positive 2. So be on the lookout for transferring the negative from the bottom to the top. It's got to go through everything in the top. And then they typically write the positive thing first. So here's just a monster of a FOIL problem because they're obviously not conjugates. These are the ones that I really think you should use a box. So 2 square root of 3, 5 square root of 2, 3 square root of 6, negative 4 square root of 5, and let's get after it. This is water and water, so that's 6 square root of 18. So I'm going to write that over to the side because I can see square root of 18 turns into 9 and 2. Now the square root of 9 is 3. 3 times 6 is 18. 18 square root of 2. Now I'm going to do the same thing here and here. 5 times 3 is 15. Square root of 6 times the square root of 2 is the square root of 12. So I get 15 square root of 12. But I know the square root of 12 breaks down to 4 and 3. Now what's the square root of 4? 2. 2 times 15 is 30 square root of 3. Moving this way, I can see 3 times 5 is 15, and that's not going to break down, so I can go right into the box. Negative 8 square root of 15. Same thing here. 2 times 5 is 10, so I can just multiply and put it right in the box. So 5 times negative 4 is negative 20, and I get square root of 10. Now, interestingly, there's no like terms. So this is just going to be one very long answer. And it doesn't matter what order you write it in as long as you keep the negatives with the negative stuff. So there it is. All right, number 7. We're just multiplying fractions. So if you remember your rule, you just multiply straight across and you get 6. That's the easy part. And if you notice, if we put parentheses around these, it might kickstart you because you're going to go, hey, conjugate, so I can foo. Square root of 5 times the square root of 5 is 5. 3 times negative 3 is minus 9. 5 minus 9 is negative 4. Over 6 would give me negative 2/3. Done. Number 8 is definitely baiting you in to canceling these, and you can't because of the plus and the minus. We talked about that again a lot in class. So all I'm caring about is the radical down here. And the only thing I have to do is multiply by the conjugate. All right, so in the top, unfortunately, you're stuck foiling. So that turns into 5 because the roots fly off, plus 4 square root of 5, plus 1 square root of 5, and then 4 times 1 is 4. Now I'm going to clean that up, add like terms. 5 and 4 is 9. 1 square root of 5 and 4 square root of 5 is 5 square root of 5. And then down in the basement, I can foo. So that'd be the square root of 5 times the square root of 5 is 5. Negative 4 times positive 4 is negative 16. That'd give me negative 11, and that would be my answer. But once again, I'm a little concerned because I think they're going to take the negative out, throw it through the top, and then they might write this one because both of them are going to be negative. Negative 9 minus 5 square root of 5 all over positive 11. Typically, they get the negative out of the denominator. One extra step. All right, now we're into some problems where we have to solve. Well, we're going to add 3. So we get 2 square root of x equals 4. Divide by 2, divide by 2. So we get the square root of x equals 2. You could go ahead and use your noggin. The square root of 4 is 2. Or you just square both sides, and you get x is 4. And you're supposed to plug these back in to make sure they work. What's the square root of 4? 2. 2 times 2, 4. 4 minus 3, 1. Yep. Check mark's a good thing. Subtract 5, subtract 5. We get the cubic root of x equals negative 2. Now you could look at this and go, aha, x is negative 8. You just know it. But mathematically, you cube this to get rid of the radical. You cube that. So you get x equals negative 8. If we plug that back in there, cubic root of negative 8 is negative 2. Negative 2 plus 5 is 3. That's a good answer. All right, this one, the radical's already isolated, so we're going to go ahead and cube that. And we're going to cube that. The roots fly off. Add 5, add 5. we get 2x is 32. Divide by 2, divide by 2. X is 16. Now don't forget to plug that back in there. 2 times 6 is 32. 32 minus 5 is 27. So we get the cubic root of 27 equals 3. Is that true or is that false? That is true, which means our answer is 16. That's good to go. All right, backside. Number 12 gets a little bit more difficult. All right, number 12, you can see we got a radical isolated. We've got this little x over here, but that doesn't bother us. You just square this side, square that side. The roots fly off. 2x plus 3 equals x squared. Look at what we got. We got a trinomial. So we got to set this equal to 0. Keep this squared term positive. So I'm going to bring all of this over. Then I get x squared minus 2x minus 3 equals 0. Now I got a trinomial. I'm going to factor it. X minus 3, x plus 1. What causes this to be 0? 3. What causes this to be 0? Negative 1. Don't you dare put those down as your answers. Plug them back in. 3 times 2 is 6. 6 plus 3 is 9. The square root of 9 is 3. And that works. So that's a winner, winner, chicken dinner. Put the negative 1 in. What's 2 times negative 1? Negative 2. What's negative 2 plus 3? That is the square root of 1. Does that equal negative 1? Here's where this gets tough. Remember, I said when you plug stuff back in, you only consider the principal, which means the positive root. So it's very strange because I know the square root of 1 is actually negative 1, but you're supposed to know that you're only supposed to be looking for the positive root. So we'd say, and that rejects itself because of that strange rule of only considering the principal root. Trust me, I understand that that's weird. Speaking of weird, this one is very strange. So what we're going to do is we're going to isolate one of the square roots. We did a few of these in our packets. So we're going to isolate the big one because it just works out a little bit easier. So this is bigger than this, so we're going to get this one alone. Equals 5 minus the square root of x. Why do we do that? Well, we're going to square both sides now. Don't you dare square this individually and square this individually. Slap some parentheses around it and then square it. So this is the easy side. The roof flies off. Over here, we got to remember that when we square a binomial, it means exactly what it says. Square the binomial. So is this conjugates? No. So we have to FOIL it. 5 times 5 is 25. 5 times that is negative 5 square root of x. This times this is negative 5 square root of x. A negative times a negative is positive. Squeeze this in here. And then the roots fly off. So it equals, if I add some like terms, I get 25. This minus this is negative 10 square root of x. And then I get plus x. Now, notice what happens. If I subtract x from both sides, things clean up real nice. And then if I subtract 25 from both sides, I get negative 20 equals negative 10 square root of x. Now I'm going to divide by negative 10. Yes, this is a hard math problem. And then I would get 2 equals the square root of x. Then I square these sides again, and I get x is 4. Don't you dare put that down as your answer. Plug it in. 4 plus 5 is 9. Square root of 9 is 3. Square root of 4 is 2. And I go, yep, 3 plus 2 is 5. So my answer's 4. Now this says find the sum of your answers. I should have talked about this, but 3 plus negative 1 is 2. But negative 1 doesn't work, so this gets a little confusing. I get that. But your answer definitely says that it's 3 because you have to throw out negative 1. This one, it's your only answer. So what's the sum of your answers? Well, it's 4. All right, that does it. I've gone over my time.